boys and girls, it's Miss Pacelle. Welcome to your first instructional video. Today, we are going to be looking at types of data. This builds on what you learned in fourth grade. Last year, fourth graders needed to know the difference between categorical data and numerical data, and you worked on generating survey questions that yield those types of data. This year, we're going to build upon it, and we're going to look at data that changes over time in addition to the categorical and numerical data. All right, the essential question that is going to guide us through this lesson: how can you differentiate between categorical data, numerical data, and data that changes over time? The verb differentiate means basically how can you tell a difference between categorical data, numerical data, and data that changes over time. Let's look at the vocabulary that you need to know when we finish today's lesson. Most of this should already be familiar to you. If not, you're going to learn what it means today. We have data, we have categorical data, numerical data, data that changes over time, survey, survey question, and yield. Let's review from fourth grade. Survey questions that yield categorical data. These type of questions yield answers that fit neatly into categories or words, categories or words. These values or observations can be sorted into groups or categories. So think about some of these types of survey questions. If you asked in a survey, what is your favorite type of movie? Or if you asked a group of people in a survey, how did you get to school this morning? Or possibly you asked, what types of shoes were worn to PE class today? All of the answers to any of those survey questions would give you answers that were words that could neatly be sorted into categories or groups, all right? This data is best displayed using bar graphs, pie graphs, and line plots. Let's take a look at these. So the favorite type of movie: comedy, action, romance, drama, sci-fi. Those would be the different answers that people might have given you in your survey question. And then you can graph it or display it using a bar graph. All right, maybe your question had to do with the way you traveled to school this morning. All right. Maybe you gave people a choice of answering with either I was a walker, a car rider, a bus rider, I rode my bicycle to school. If we lived in a big city, you might have ridden a train or a subway to school, or you might have taken a taxi to school. So again, when you would ask that question, the answers that you get back from the people you survey would fit neatly into those categories. And here's an example of displaying that data on a pie graph. And then the last one, if you surveyed people in the school to find out what kind of shoes they wore to PE, you might find that some of the children that you surveyed have specially designed running shoes, or specific shoes made for walking, or just a generic tennis shoe. All right, and then this graph should look familiar. This is a line plot, and if you remember, each of those X's represents a response from one of the people that you surveyed. All right, let's review survey questions that yield numerical data. So these questions yield responses that are numbers. These values or observations can be measured. Numerical data answers are numbers, so they can be placed in ascending or descending order. That means we can order them from least to greatest or greatest to least. So let's think about some examples. The time it takes you to get to school. What your grade is, not A, B, C, D necessarily, but what percent. And then we can always, if it's a 90% to 100%, group it as an A. If it's a 80% to 89%, we can group it as a B. But what percent? What's your grade? And the number of candy bars that you consumed in a week. All right, this data is best represented on bar graphs, pie graphs, and again, line plots. So here are some examples. So look at the first example. If you asked a group of people, if your survey question was, how long does it take you to get to school in the morning? You would have answers that came back as numbers. Around here, it definitely would be minutes. So you might have 15 minutes, 20 minutes, 25 minutes, 30 minutes. If you look on this bar graph, it took some people between 40 and 45 minutes, and it took some people between 40 and 50 minutes. So your answers would have required somebody to use a clock and measure the amount of time it took to get to school. So this is a numerical data type of question and representation on a bar graph. Look at the pie chart. Student grades. Now these grades would have been a percentage grade. So maybe you had an 89% in social studies. That would be a B, right? So once that data was collected for the pie graph or the pie chart that we see here, then we relabeled it as an A, a B, a C, or a D. All right, the candy bars, the number of candy bars that you ate in a week. All right, if you take a look at this, again, you've got a line plot. When you ask that question, you're going to have answers with this population between 0 candy bars eaten in a week to 8 candy bars eaten in a week. So these are good examples of survey questions that yield numerical data. Now, some numerical data changes over time. And this data that constantly changes is going to be represented on a line graph. So examples, and if you look below at these line graphs, examples include, maybe I want to look at the daily high temperatures for a week. So between Sunday and Saturday in this particular city, we're looking at the temperatures. And if you notice, the temperature ranges are on the left side on the vertical axis, the y-axis. All right, another good example of data that might change over time. Maybe you're selling cookies for a fundraiser, and we want to look at the number of cookies you sold each day of the school week, so Monday through Friday. And then if you look, this particular person sold between 1 and 10 cookies during the week, and we can look at that data. It changes. It's not the same amount every day. So this is why it's great to organize this information on a line graph so we can see those changes. Another good example of data that changes over time is look at the rainfall during the first 9 days of a month. We can look at the first 9 days and we can see how many inches of rain in millimeters had occurred. So the number of inches of rain in millimeters is represented again on that y-axis, that vertical side numbering on the left side of your graph that goes up and down. All right. So again, we are looking at data that is numerical that changes over time. All right, I love a good comparison chart. It just lets me kind of look at the different features. So when I look at a comparison of the categorical data, the numerical data, and the data that changes over time, let's go through the first row. In categorical data, the responses are words, whereas in numerical data, your responses are numbers, and somehow math is applied. Maybe you had to count, maybe you had to measure, maybe you had to weigh something. All right. But data that changes over time, again, just like numerical data, your responses are numbers, but they differ because they change over time. All right, let's look at the second row. Categorical data. These responses can be sorted into groups or categories, whereas numerical data, the responses are numbered and they can be placed in ascending or descending order. And again, that means least to greatest order or greatest to least order. And data that changes over time, these values or these numbers constantly change over time. Let's look at the third row of comparisons. So these are just some examples. So in categorical data, you might be looking at somebody's gender, somebody's eye color. You might be asking about their grade level or their favorite candy bar. In numerical data, You might be asking how tall they are. You might be asking their arm span, if they stretch out their arms as far as they can left to right. How far is it in inches, perhaps from fingertip to fingertip? Or you might be looking at their weight. Here in the US, we'd be weighing ourselves in pounds. Data that changes over time. Some good examples might be the daily high temperature in Hickory, North Carolina for the month of August, how much money Mrs. Dubois saved each week from her paycheck and put it in her savings account during the year 2019. Another great example, maybe you are collecting data on how much your puppy weighed the first of the month during their first year that you had your puppy. So you're looking at how your puppy grew over the year. And then your last row, just the different ways they are displayed. If you notice, we actually display categorical data and numerical data in the same format. We would use pie graphs, bar graphs, and line plots. The difference would be this data that changes over time, and we use line graphs for that. All right, let's see how well you have mastered what we've been talking about. Let's see if it's sticking with you. So can you correctly identify whether these survey questions yield categorical data, numerical data, or data that changes over time? And that word yield, I hope you see from context, it means to produce or provide. So we could say, can you correctly identify whether these survey questions produce answers that are categorical data, numerical data, or data that changes over time? If you would, you're going to pause the video here. That's the beauty of having a video running. Number a scratch sheet of paper 1 to 10. And then I would like you to answer the question. You can abbreviate categorical data with a C, numerical with an N, and maybe use a T for data that changes over time. So I will read these. You write down the response that you think is correct. You can pause and rewind if I read too quickly. All right, here we go. Number 1, how many letters are in your first name? Number 2, what type of pizza do you like best? Number 3, how much does your backpack weigh? Number 4, what were your times on the 1-mile run over the past year in PE class? Number 5, what is your favorite subject in school? Oh, I hope everybody's answering math. Number 6, what was the daily high temperature in Hickory for the past 10 days? Number 7, what day of the week is your favorite TV show? Number 8, how long does it take you to clean your bedroom? Number 9, what is the primary language spoken in your home? And number 10, how many hours did you sleep last night? If I read too fast and you couldn't keep up, all you need to do is pause the video and answer your questions now. All right, let's look at the answers. Number 1, how many letters are in your first name? That would be numerical data. You are counting those letters. Number 2, what type of pizza do you like best? That would be categorical data because you're answering in a category or with words. Number 3, how much does your backpack weigh? Well, I think you're going to have to put it on a scale to figure that out. Your answer is numerical data. Number 4, what were your times on the 1-mile run over the past year in PE class? That is data that changes over time. Number 5, what is your favorite subject in school? That would be categorical data. Number 6, what was the daily high temperature in Hickory for the past 10 days? That data changes over time. Number 7, what day of the week is your favorite TV show? That would be categorical data. Number 8, how long does it take you to clean your bedroom? Again, you'd have to time yourself. That would be numerical data. Number 9, what is the primary language spoken in your home? Categorical data. Number 10, how many hours did you sleep last night? That, my friends, would be numerical data. If you need to pause the video and check over your work, look at any that you missed and analyze why you missed it, this would be a good time to do that. All right, here's a tip for you. These are the things that I kind of think aloud to differentiate between the categorical data, the numerical data, and the data that changes over time. So when I ask a question that yields categorical data, I realize that my answers, or the answers that people would respond with, are words, and they fit neatly into categories or groups. When I ask a question that yields numerical data, I notice that the answers are always numbers. Some kind of math is involved. This is different than when I ask a categorical question. And then last but not least, when I ask a question that yields data that changes over time, I notice that the answer always changes over time. Why is today's concept important, you might be wondering? Well, knowing the type of data a survey question yields is important because it's going to affect our decisions about how we will organize and display the data in our next few lessons this week. All right, boys and girls, I'm going to stop the video right here. If you need to rewatch it, if I went too fast, if you just need a little bit more time to digest the information, please take a couple minutes, go back through it. Those of you that are ready are going to work on your independent practice assignment. In your Google Classroom, under week 3 for today, I have a link to a Google form where I have asked you or given quite a few survey questions, and all I want you to do is tell me, will that survey question yield categorical data, numerical data, or data that changes over time? And once you have finished and looked over your answers, then I would like you to click the submit button at the bottom of the form. Reminder, if you do not click that submit button, when I go to look at your work tonight, what I'm going to see is that you didn't do it. I am sure that if you took the time to do your assignment, you would like credit for it. So make sure you click the submit button. All right, boys and girls, have a great day. If you have any questions and you don't have anybody at home that can answer them for you quickly, send me an email. I will get back to you as soon as I can. Have a great day. Do your best.